And if you go on the web, you can still find many of them, but most of them don't have any data to support them. So this cartoon is my favorite theory for the extinction of the dinosaurs, which is that they died from smoking cigarettes. And the reason I like this is because it's a testable theory. There are no cigarette butts in the boundary layer that marks the extinction of the dinosaurs. So we know that this theory is wrong. But there are lots of other theories that people have suggested. An American paleontologist a few years ago suggested they all died of the flu, an untestable theory. And why would plankton die from dinosaurs catching the flu? Doesn't make any sense. Harold Urey, who was a famous geophysicist, won a Nobel Prize in the 1970s, proposed that the dinosaurs were killed by asteroids and comets colliding with the Earth. That was the end. That was the explanation for all the geologic eras. And no one paid any attention to that theory because it didn't have any evidence. So the reason that this has become a theory that's widely held now is because of the people on the right of the screen, Louis and Walter Alvarez. So Walter is a geologist who was studying the geology of northern Italy. And Louis Alvarez on the left was a Nobel Prize winner in physics for inventing the bubble chamber. And coincidentally, he was on an aircraft that flew along when the atom bomb was dropped on Hiroshima. His job was to measure the yield of the weapon. So Walter has his hands on a little piece of strata there that was pointed out to him by some geologist. Walter was interested in dating the spreading of the oceans back in a time when continental drift had just been discovered, and people wanted to know how long it took to make magnetic reversals. And he could tell this because in this long stack of limestone, they could date it by looking at fossils, and they could also find the magnetic reversals. But someone else pointed out to him that there was this interesting layer there that marked the extinction of the dinosaurs. On the left, you can see my hand pointing at the layer where it's exposed where I live in Colorado. So there are exposures of this geologic layer all across the world. It's a centimeter or so thick in North America. Then in most of the Earth, it's only a few millimeters thick, so it's a little more difficult to find. Louis and his son knew that there was a constant rain of micrometeorites on the Earth. There's about 40 tons a day of microscopic particles falling on the surface of the Earth from outer space. And so they wanted to know how long it took for the dinosaurs to become extinct. So they knew that they could look in that layer that's underneath Walter's hand and measure things that were only found in asteroids, like iridium. So iridium is what's called a siderophile element, meaning that it loves iron. So when the core of the Earth formed, iridium and other iron-loving elements moved preferentially to the core and were depleted in the crust. But most asteroids are not differentiated, and so they're rich still in iridium. So they looked at the chemistry on this core and discovered it was had a very high concentration of iridium, so that instead of representing a slow rain of micrometeorites, it was represented a single large asteroid collision with an asteroid about the size of Mount Everest. And they deduced from knowing the speeds of asteroids, it would probably hit the Earth at about 10 times the velocity of the fastest bullet coming from a rifle. So the energy of this is something like 100 million megatons of energy. This is equivalent to having a 1 megaton nuclear bomb blow up about every 5 kilometers across the whole entire Earth. So it was an incredible amount of energy in this collision. We can look at this layer and find out what's in it and learn what caused the extinction. So the first thing we see is this little grain here with colored stripes under a polarizing microscope. This is a grain of quartz, and those little polarized stripes are shock waves, remnants of shock waves that probably created across a grain. And people know that these kinds of shock waves are only found around other craters. And so they're a sign of an impact. Volcanoes can't make such a grain of quartz. And so this is one reason why we're pretty sure that this was not a volcanic eruption that killed the dinosaurs. The other thing that's found in this layer are these little spheres. These are about the size of a grain of sand, 100 or 200 microns in diameter. And these are basically shooting stars. So the normal shooting star you see when you go outside and look up is a sand-sized grain of interplanetary material. When they enter the atmosphere, they get heated by friction and they leave behind a glowing trail. And so in the case of the extinction of the dinosaurs, this is not your normal one shooting star per minute. There are about 10,000 shooting stars per centimeter squared on the ground in the layer where the asteroids were died. So the whole entire sky was bombarded at once by a basically countless number of these shooting stars. Come back to what that did in a minute. A surprising thing that's found in this layer is elemental carbon. So if you look at these electron microscope here, this is about 1 micron across. These are little so-called monomers of black carbon, and they like to form little fractals, chains of black carbon. This looks just like what you see from a normal forest fire. And we believe that this elemental carbon was formed because basically everything flammable on the surface of the Earth, and probably some stuff buried in the subsurface, burned. So somehow, and this is a great puzzle how this happened for a while, the asteroid ignited everything on the surface of the Earth. There are other things there that are much harder to quantify. There's some small dust particles. We know this because we know there's nanometer-sized iron particles there, but we can't quantify the amount of iron. And there's probably quite a bit of sulfur here. Asteroids are rich in sulfur, but so was a target in Mexico that the asteroid hit. And some people think the sulfur is what killed the dinosaurs. But basically what happened is that when the asteroid hit the Yucatan Peninsula in Mexico, just out in the ocean from there, it made a crater that's about 200 kilometers across, and it blew a huge amount of material back out into space, which probably went thousands of kilometers into space and distributed itself over the Earth and fell back with a significant fraction of the asteroid's energy. When that entered the atmosphere, it heated the upper atmosphere, probably to around 2,000 degrees centigrade. So what do the dinosaurs see when they're looking up? It was probably something like this. So we think what happened is that there are very high radiant intensities from the shooting stars. There was a hot layer, it was optically thick, it was 2,000 degrees centigrade. This artist captured it, except that probably stuff wasn't really falling on the dinosaur's head. It probably took a few days for these little particles to fall out. They probably felt something like an ice storm. Didn't hurt the dinosaur. Instead, what the dinosaur really saw was something that looked like this forest fire here, red, hot, glowing skies. So this is not like a normal day. It's not a point source like the sun. The sun casts shadows behind objects. But in this case, the entire sky was glowing red hot, and there were no shadows. So there was no place for a big animal like a dinosaur to hide. And so they probably were simply broiled alive. So this is an experiment you can do at home. If you like, you can go down to the grocery store and buy yourself a dinosaur, like a turkey or a chicken, and take it home and turn your oven on broil. If you turn your oven on bake, lots of people bake turkeys and chickens in ovens, and you can bake them and it's not too hot. But when you turn your oven on broil, the glow bar in the oven is radiating at about the same intensity as the sky was. And that will burn your chicken or your turkey or your avian dinosaur and would have killed it if it had been alive. So that probably killed a large fraction of the non-avian dinosaurs. Of course, that's not the only thing that happened. If you burn everything on the Earth, you create a huge amount of smoke. And we know about how much mass of smoke there was because we have this layer down here. So this is a coal layer that formed after the extinction. So these are some of the shooting stars. And this layer, as I mentioned, is full of this soot. So we can quantify the amount of soot that was involved in this. It's about 15,000 million tons of black carbon. So we'd like to know what happens when that was in the sky. We can put it back in the sky. And it's pretty easy to calculate what its optical depth was. So the back of this car, this isn't my car, but my car often looks like this. You can see someone has written words in the dust. So this is one meaning of optical depth. If you take all the aerosol in the atmosphere and you drop it down to the ground and make a layer out of it, if it's one layer of particles thick, it's about one optical depth. So since we know the mass in that layer, we know how many layers of aerosols are there, we can use this graph. And so this is optical depth along this axis, which is the same as layers of black carbon. And there's about 15 layers there. And that would yield a transmission of about 10 to the minus 8. In other words, 1 part in 100 million of sunlight would get to the ground following that injection of that smoke. So the limit of human vision is about 10 to the minus 10. Your eye's logarithmic. You can see a huge range of light intensities. So you'd still be able to see. It would be like a moonless night. A full moon night is like 1/1,000,000th. The limit of photosynthesis is about 1%. A very cloudy day is about 10% of normal sunlight. So it basically would look pitch dark to you. You could barely see. So what does this mean? So there was a huge extinction in the ocean. Altogether, about 50% to 75% of the species on the planet died in this extinction event, which was one of 5 great mass extinctions. And in the oceans, what probably killed the animals was that sunlight was lost. Plankton couldn't reproduce anymore, and the food chain collapsed. So this is an interesting thing about the Earth. On the land, we had a food triangle. We have a food triangle. So there's a lot of food at the base in the form of plants and insects and small creatures. You know, then there's cattle and pigs and things like that that eat those. Then there's mammals and carnivores at the top that eat those. And where I live, there's mountain lions at the top that eat everything else. So there's a pyramid, and it takes about 10 years to reproduce the carbon at the base of the food chain on the land. So even if you destroy a lot of the surface vegetation by burning it, there's still a lot of food left in the soil, and there's enough food there to feed the biota for a long time. But the ocean does not have a food triangle. It has a food square. So the amount of mass in phytoplankton is about the same as the mass in zooplankton and fish. So the fish and the zooplankton eat the phytoplankton every few days. And so the turnover time of carbon in the oceans is about 10 days. So after 10 days of no light, the plankton had basically vanished, and the food chain will collapse, and the zooplankton will die, and then the fish will die, and the large animals that might be able to go a long time without eating will also eventually die. And so creatures like this creature is called a bonarichthes. It was kind of the whale shark of its day, although it's not a shark. It swam along with its mouth open, filtering plankton. So these creatures went extinct, as did lots of other creatures in the oceans. So the pattern of extinction in the oceans is that if you lived in the photic zone in the top few hundred meters of ocean, which is driven by photosynthesis, you probably went extinct. If you lived in the deep ocean and you made your living eating dead stuff, dribbling down into the bottom of the ocean, you're much less likely to go extinct. So there's a pattern there. And it's explained largely by this, the loss of sunlight. Of course, if you lose all that sunlight, other things are going to happen. It's going to get very cold on the land and in the sea. And so this is an example of the surface temperatures calculated from general circulation model at the National Center for Atmospheric Research in the United States. And so this is a surface temperature on the second year after the event. The color green marks the freezing. So you can see temperatures are basically below freezing on an annual average all across the continents. It was not below freezing in the oceans, but it was much colder than normal. So you can see temperatures here, maybe 280, 290 degrees, which is 10 or 15 degrees colder than normal. So if there are any dinosaurs that survived, they were lingering in the dark for a couple of years, or remained dark for a couple of years. I'll show you some numbers on this later. So it was pitch black below the photosynthetic level for about 2 years. Basically everything dinosaurs would have eaten on the surface died in the fires. And it was quite hard for a dinosaur to eat anything because they couldn't see because it was pitch dark. And it was well below freezing across the earth. So this was undoubtedly a big extinction mechanism. So the next question, of course, that arises from that is, how did anybody survive? How did our ancestors survive? And so mammals had been on the planet almost as long as the dinosaurs, about 200 million years. Mammals were not a successful group against the dinosaurs. They were not suddenly becoming dominant over the dinosaurs by eating their eggs, anything like that. They were just in a kind of hanging around at night when the dinosaurs weren't looking around for them so much, and living in little holes in the ground like this little fellow, who's probably similar to a creature at the time of the extinction. So this guy survived by having a hole in the ground, and this is a pattern on the land, nothing very large, nothing larger than a modest sized dog survived. Most of the ones that survived, the ancestors appear to have lived in little holes. So you go down a meter or less, you're sheltered from the fires. You can stay down there and escape the cold. There's plenty to eat in terms of roots and insects. And the same thing is probably true of birds. So this is a living dinosaur here, this parrot hiding in a termite mound. So the birds may have survived in a similar way by hiding in holes. A lot of the bird ancestors we know about lived at the shoreline or in swamps. So they may have survived the fires by hanging out in the water and then surviving with food along the coastline. Of course, you could also ask, what if we didn't survive? Our ancestors hadn't survived to take over from the dinosaurs. So obviously this is an accident in Earth history that we got hit by this carbonaceous chondrite meteorite. And so Dale Russell, who's a Canadian paleontologist, imagined who might rule the Earth now if it hadn't been for the asteroid. So this creature in the background, we call it Troodon, and he was one of the more intelligent dinosaurs based on the size of his brain to body. I tell people he was one of the most intelligent dinosaurs based on brain to body size, probably about as smart as an armadillo. I don't know if you have armadillos in China, but probably like a pangolin. Probably not too smart either. And he imagined, Dale Russell did, that this creature would have become totally bipedal and would have had large eyes to see with. He thought it might have developed a belly button because it probably would have had live birth, although dinosaurs propagated by eggs. As you can see, it only has a few fingers, very handy for cartoonists who like to draw people in cartoons only having 3 fingers. Of course, there was a lot of complaint about this hypothesis of Dale Russell's, And many other people said, well, this could have evolved in lots of different ways, and it didn't have to end up looking like Dale Russell. So it's an interesting question as to what would have happened without the asteroid. Okay, let's change subjects now and talk about nuclear weapons. So nuclear weapons were developed in the Second World War by the United States and Britain. There were about 70,000 of these in 1986 on the planet. You can see the numbers rose rapidly here until the mid-1980s, and then the numbers became reduced. There have been a bunch of games being played by politicians and how you count them. So this total number used to include tactical nuclear weapons and all the nuclear weapons there were, but starting at about 2000 in the Bush administration, and they decided instead to only count the nuclear weapons that were deployed, strategic nuclear weapons. And that's what's limited in the only existing treaty that's still around. So Russia and the United States are both limited to having about 2,000 strategic deployed nuclear weapons. So what happened at this peak, 70,000 nuclear weapons? There are only 500 cities in Russia and the United States total with more than 100,000 people. One does not need to have 70,000 nuclear weapons. Even now, when there's 4,000 nuclear weapons, there's still only 500 cities in Russia and the United States. You don't need 4,000 weapons to attack 500 cities. There's like 8 weapons attacking every city with more than 100,000 people. So there was totally overbuilt here in the mid-1980s. So the United States politicians have lost interest in science. It's under attack constantly by politicians who don't want to hear about things like global warming. But that wasn't true in the 1980s. So these are some quotes by President Reagan and Mikhail Gorbachev, who was the president of the Soviet Union at the time. So Gorbachev, this is after 1986, said, climate models made by Russian and American scientists show that a nuclear war would result in a nuclear winter that would be extremely destructive to all life on Earth. The knowledge of that was a great stimulus to us, to people of honor and morality, to act in that situation. Ronald Reagan said, a great many reputable scientists are telling us that such a war could just end up in no victory for anyone because we would wipe out the Earth as we know it. And if you think back to natural calamities back in the last century in the 1800s, volcanoes, we saw the weather so change that there was snow in July in many temperate countries, and they called it the year in which there was no summer. Now, if one volcano can do that, what are we talking about with a whole nuclear exchange? The nuclear winter that scientists have been talking about, it's possible. So Ronald Reagan, this quote is before the treaty between Gorbachev and Reagan, understood the mechanism behind nuclear winter that I'm going to describe to you more. So this build down in nuclear weapons that took place starting in 1986, and it's continued ever since, was started by Reagan and Gorbachev because the science community told them nuclear winters were going to destroy the civilization on the planet. And this build down has continued by every American president since then, and by every Russian leader since then, even by Donald Trump, who probably didn't want to continue the build down, but did anyway. Unfortunately, the treaties that stopped this was taken down by Donald Trump. So we no longer have a constraint on these weapons in Europe, which was put in place. This was a treaty involving weapons in Europe. It started this, but then there were other treaties that limited them between the US and Russia. Of course, there's other countries with nuclear weapons. So there's about 1,250 nuclear weapons currently between Britain, China, so this is China here, France, Israel, and Pakistan and India. So you can see that most of these countries are aiming at a number of nuclear weapons between 200 and 300. None of them explain why they have picked that number, possibly because any adversary that they're likely to attack has a number of cities like 200 or 300. So India and China are exceptions. They have like 400 cities with more than 100,000 people in them. You see India and Pakistan are rapidly building up their arsenals, which is very dangerous since they have conflicts with each other frequently. So this is another way of looking at the current inventories. So we can see there are about 6,000 weapons in each of Russia and the United States. China has 350 and so on. So although these countries over here have smaller numbers of weapons, as I'm going to show you, even a war between Pakistan and India could end up killing between 1 and 3 billion people if these were used. Clearly, a war between India and China would end up killing potentially half the people on the planet. The United States and Russia have treaties which have regulated these deployed strategic weapons down here to around 2,000 each. There are other games being played there that counted one bomber as one missile. An American bomber has like 16 nuclear armed cruise missiles on it. So that's a miscount. Then there's another 2,000 weapons in each country that are stockpiled or in reserve, which could be brought out at a time of tension. And then there's some weapons that are being retired. So there's a complicated series of weapons here. In addition to this, Russia has about 2,000 tactical nuclear weapons, which could have the same yields as strategic weapons, which would probably be used against NATO in the event of a war. So what happens when you explode a nuclear weapon? We know this from 500 above ground nuclear weapons tests before 1963, and also from places like Hiroshima, which is pictured here. So the bomb fell. This is close to ground zero. It was an international exposition center before the war. It's still preserved as a memorial. And you can see all this rubble around here. There was about 13 square kilometers destroyed in this explosion. It was not destroyed by the blast. This is the result of a firestorm that burned everything to the ground in this region. And you can see these concrete buildings were left standing, but they were all burned internally so that very little was left inside of them. So the destructive force here was caused by a firestorm, not by the blast. We've even seen the same kind of a picture from places like San Francisco, which had a big earthquake in 1908, and a firestorm started there and produced the same kind of an image. What would happen in a modern city? So here's just an example from Hong Kong. So this is from a web tool called Nuke Map. You can attack any place you want on the earth with any sized weapon and see how many fatalities there might be. So in this case, there's a zone out to this range here, which is about 6 kilometers in radius, which would all be burned. There's another range here, not quite as far, which would all be destroyed. Weaker buildings like made of brick or wood would be destroyed by a blast wave. Then inside here, there's a stronger blast wave that would knock down even concrete buildings. And in here, there would be radiation from the nuclear fission reactions that were producing the explosion of the bomb. So altogether, 900,000 people are expected to die from this one explosion of a 100 kiloton nuclear weapon, which is the smallest nuclear weapon carried on an American submarine. And it's about the smallest weapon in the Soviet or Russian arsenal. So this is a very small weapon doing this kind of destruction. The number of people that die depends on the density of the population, of course. And so Beijing suffers about a third as many casualties because it's not as densely populated as Hong Kong. One can evaluate the fatalities in wars, assuming that urban areas are being attacked by these weapons. So this is from a Physics Today article in 2008. So this is people affected versus the number of 100 kiloton explosions. The average yield of a nuclear weapon on the planet is around 300 or 400 kilotons. So it's bigger than the yield here. So probably in a war in which China was attacked with 1,000 weapons of the average yield, something like 200 million people would be killed from the explosions. And in the United States and Russia, probably 50 to 75 million people would be killed outright. So the fatalities around the Earth from what's called assured destruction by the American military, meaning they are sure that this would happen if you attack these cities, because it's just blast waves. They have great confidence in calculating blast waves. This is assured destruction, hundreds of millions of people. But that's not actually the greatest danger. So this is a picture that tries to explain where I'm headed in this talk. So this is supposed to be a farmer standing in a field in Europe, or maybe China, or maybe the United States. And there's been a war between India and Pakistan involving a small number of nuclear weapons, maybe 50 on each side. And it's burned a bunch of cities in India and Pakistan. And that smoke is spread across the planet and it's blotting out the sun. And as a result of that, it's cooled off. It's not snowfall, it's not ice, but it's cool, cooler than normal. And there's less sunlight reaching the ground, so his crop has died. And so you get an agricultural failure due to this. So we know a fair amount about fires. We know that they occur after nuclear explosions. A nuclear explosion is like bringing a piece of the sun to the ground. There's a bright burst of light that can start fires. And of course, when you knock down all these buildings, more fires can start. This is a picture from Hiroshima about 3 hours after the nuclear explosion. And this is a pyrocumulus, a thunderstorm generated by a fire. Above Hiroshima, the top of this cloud is about 16 kilometers above the surface. So this cloud is penetrating the stratosphere. So the lowest layer of the Earth is called the troposphere for turning. It's turbulent motions there and rainfall. The stratosphere is stratified. There's no rain in the stratosphere. What this means is that when you have a normal fire, a normal forest fire, the smoke only stays in the troposphere for a week or 10 days at the most. But if you put smoke in the stratosphere, it will remain there for months or even a year because it doesn't ever rain there. So we've observed this in the last few years with satellites. So this is an example from a fire in Canada in 2001 called the Chisholm Fire. And this is an airplane picture of the side of the pyrocumulus. So you can see it's full of smoke. There's some water up here on the top of it that's white. It's been condensed in the atmosphere, but it's full of smoke. And if you look at it from a satellite, you can see that it hit the tropopause, which is why it flattened out like this and probably penetrated it. And we know from satellites that some material entered the stratosphere. So how much smoke would be generated by a nuclear war? So this involves China, the US, and Russia again. Teragrams are the same as millions of tons. And so we're expecting that burning cities in Russia and the United States from around 1,000 nuclear weapons would generate somewhere around 70 million tons. And from China, where there's more material and more people, around 80 million tons. So altogether, around 150 teragrams or 150 million tons of soot, black carbon, might enter the stratosphere. 150. The dinosaur case I talked to you about before was 15,000. This is 150. So the dinosaurs extinction event was 100 times more black carbon than we calculate might come from a nuclear war. Okay, so what else have we learned? we learned from fire in 2017 that if you inject material, which was a few days before the start of this graph, into this lower stratosphere, upper troposphere region, the sunlight will shine on the smoke and heat it. And so the smoke, even a little bit of black carbon, will rise to high altitude in the stratosphere. And so this was injected down near the tropopause, 12 to 13, 14 kilometers. This dashed or X curve is a satellite measurement of the height reached by this. You can see after about 10 days, you get up to 20 kilometers. And these are simulations from a numerical model, the rest of the curves. And the model reproduced this rise of the smoke, which was predicted in nuclear winter models in the 1980s. Okay, so what do we expect to happen in a war? So this is an example of an India-Pakistan war starting on the 15th of May. And so on the right, we see the smoke spreading across the Earth. So as I'm going to show you in a minute, the temperature in the stratosphere is perturbed by about 50 degrees centigrade by this black carbon absorbing sunlight, which generates strong winds. And within a month, which is the 15th of June, the black carbon is reaching Antarctica. And these little numbers here are the optical depths. You know, they're not huge, 0.07 or something like that. But even a little bit of black carbon in the stratosphere has very large effects on the climate. We would never want to inject black carbon on purpose into the stratosphere. And over here on this side, you can see the altitude that the black carbon has reached. It'll restart in a minute. Originally it was injected below the tropopause down here. And you can see it started rising rapidly. And within a few weeks, it's propagated up to about 80 kilometers. And the centroid of this here is 30 kilometers. The center is between 30 and 40 kilometers. So this has risen far above the place where you get any rainfall. What does this do to the temperature? So this is a 1,000-year record of temperature. This is a so-called hockey stick from those of you who are familiar with greenhouse warming. This part of the record comes from tree rings and things like that. And this is a thermometer record coming from measured temperatures. So this imaginary nuclear war started up here at a warm state from the enhanced greenhouse, and the temperatures dropped to the lowest that have been seen since the end of the last ice age. This is from a war between India and Pakistan involving 100 nuclear weapons of the same yield that Hiroshima had and releasing 5 teragrams of black carbon. The little ice age is this little area in here where it's slightly cooler. The year without a summer is right here, which caused global problems, probably from the big volcanic eruption. So this is colder than the little ice age, and it's colder than the year without a summer. So we got cool at the surface. It's not tremendously cold, you know, it's only half a degree centigrade or something like that in this example. In the stratosphere, it got very hot. It's 30 degrees centigrade warmer than normal for almost 5 years because of the absorption of sunlight by the black carbon. This changes a bunch of reaction rates in the ozone, and you end up with a global ozone loss. So this is a typical ozone distribution on the Earth. It's measured in something called the Dobson unit. And so in here, you can see at high latitudes in both hemispheres, you get around 400 Dobson units. These little dots mark the edge of the ozone hole. And so the ozone hole color is blue. And within this region, ozone levels drop below 100 Dobson units. After this war, the entire globe is under ozone hole levels of ozone. This would be a serious ozone loss. You wouldn't be able to walk outside, stay outside for very long before you'd have a bad sunburn. So a war between India and Pakistan would be devastating. Of course, a war involving the United States and Russia, which might or might not involve China, with the START arsenals. So these are agreements reached between Obama and Medvedev, who was then president of Russia, that gave each country 2,000 nuclear warheads at the present time. So what does this really mean? So this is a Trident missile carrying submarine. There's probably a couple of them that are parked in the Pacific Ocean off the coast of China and Russia. One of these submarines has the power of 1,000 Hiroshima bombs. These submarines can carry 100 missiles, and each missile can has, I'm sorry, not 100 missiles, 100 warheads on missiles. The missiles have multiple warheads. And each one of these has a power that's about 10 times the Hiroshima bomb power. So 100 warheads instead of one, 10 times the power, that's 1,000 Hiroshima bombs in this one submarine. So this is one of these is capable of devastating a country like China, for example. So I mentioned you might have 150 teragrams of 150 million tons of black carbon in a nuclear war between the US, Russia, and China. This is the hockey stick again. This is a temperature drop from an India-Pakistan war. And this is a temperature drop we think would occur from a war between these three countries. Ice age temperatures are much warmer than that. So these are sub-ice age temperatures. We can compare the temperature drops and the drop and the loss of light from a range of wars. So this is the smallest war between India and Pakistan. But India and Pakistan are rapidly building up their arsenals. We don't know how big their weapons are. If they're as big as the weapons that North Korea have recently tested, the red curve might apply. If it's an Hiroshima-sized warheads, the blue curve might apply. So this is a loss of sunlight after a war between India and Pakistan, or maybe one between the United States, Russia, and China. You can see you're losing tens of percent to 40% of your sunlight to 70% of your sunlight. This is going to cause a large, well, I'm comparing with the dinosaur case. So the dinosaur case here is this black line. So this dropped light levels to 10 to the minus 9 of normal. It was below 1% for about 2 years. It's going to cause photosynthesis to stop. So this is much more extreme than the Russia-China-US war, which is up here at about 70% light loss. And so it probably won't stop photosynthesis to have a war like that. So we can compare the global temperature changes. So India, Pakistan, this is a 16 teragram war, which would involve 50 kiloton weapons. 3 degrees, the US, Russia, China war, 9 degrees, and the extinction of the dinosaurs about minus 15 degrees, which is at the global freezing point. With less sunlight reaching the ground, there'll be less water evaporation and less rainfall. So rainfall drops 40% or 60% in the US, Russia, China war, 40% of normal. And after the dinosaurs, it probably dropped to 20% of normal. The ozone layer is going to be destroyed in all these cases. So here you lose 40% of the ozone layer, and here you're losing 60%, and only 20% left after the extinction of the dinosaurs. Lots of ultraviolet light would reach the surface. So we can understand a little better what this means by looking at a couple of places. So this is an analysis of what happened in Iowa and what would happen in the Ukraine. These are two major grain growing places. So the earth is dependent on agriculture in these places. So this is temperature from departure from a normal here, or from freezing. This is freezing, solid curve. This is time here for 2 years, and the war starts right here. Normal temperatures would go up in the summer, down in the winter, and up in the summer. In this case, they immediately collapse below freezing. They stay below freezing all the next year, all through the next summer. There's no day, even a year later, where the temperature is above freezing for part of the day, except this. There's no day here. It takes 2 years before the minimum daily temperatures to get above freezing, and even there, they're not very warm. So what does this mean? There's an agricultural collapse. So this is part of a paper that is still in review, in which we have evaluated the agricultural losses in every country in the world following a war between Russia, the United States, and China. That's the gray curve or brownish curve over here at this point. And the rest of these points here are for India-Pakistan wars. And there's lots of details in agricultural loss. And so this one here assumes that you continue to keep animals like cows and pigs alive. And these assume that you keep the food that you would have fed to this livestock, and you eat the food that they would have eaten yourself. However, a lot of that grain isn't going to become available either because of the collapse. And so probably the real answer is between this greenish curve and this brown curve. So you can see here in an India-Pakistan war, this is a range of possible wars because we don't know what the yield of their weapons are, how many they would use. Somewhere between 1 billion and 3 billion people starved to death. This is a war between India, Russia, and China. Probably 6 billion people starved to death. So this is a misconception a lot of people in the West have, because there's a story in the Bible and there's also a story in the Quran in which the Pharaoh in Egypt is advised, based on his dreams, to store grain for 6 or 7 years because there's going to be 7 years of famine in Egypt, and he needs to feed the Egyptians for 7 years. So a lot of people in the West think that there's 7 years of food in the store, but there's not. There's 60 days of grain in storage on the earth. After 60 days, there's nothing to feed people on the earth. The earth works by transportation. The southern hemisphere is raising grain where the northern hemisphere is not. It's transported back and forth across the earth. Russia raises lots of wheat and sells it to the Middle East. China raises lots of rice and trades it to different places. We're not used to this kind of a situation where there's a global catastrophe. We can't make up for it by shipping grain around, which is what we do now. If Russia has a grain failure, for example, it had a famous one in the Carter administration of the US. The US, even though it was an adversary of the Soviet Union, shipped them huge amounts of grain so they wouldn't starve to death. And that happens every year on the earth that someone has crop failure. But this will be devastating after a nuclear war. And it's dependent on what country you're in here. And so different colors on these maps are different percentages of the population that dies. Let's just take the 150 teragram case, although this somewhat propagates through all of them. So less than 1% of the population survives in a country that's dark brown. So if you're at a high latitude, relatively speaking, or you raise a lot of grain in relatively cold temperatures like Canada and like Russia and like lots of China, less than 1% of the population is going to survive in those countries. It's not quite as bad if you don't keep the livestock alive, but still Russia is going to suffer huge damage. In fact, even a modest war between India and Pakistan could kill 75% of the people in Russia if there's no trade. So this is very serious, and it's especially serious in some countries. Others would survive okay. You can see Australia does all right here, and it's because they're fairly close to the equator, so they're not a high latitude country, but they also raise a lot of sheep, and so they can just eat the sheep instead of exporting them. So there's a lot of details in these agricultural situations. Okay, so I'm just about done here. And so we have a lot of examples from nature of what will happen. We can't do the experiment of a nuclear war. So we have to depend on models. We also have a lot of natural examples. So we've seen these interesting fires, large fires that put smoke in the stratosphere, which stayed for several years. Peng Fei Yu, who's a faculty member in China now, that was once one of my students, has made a name for himself by examining the smoke from these fires in the stratosphere. lasting for a couple of years. So this is about 0.01 teragrams of black carbon. And then we think we know what happened to the dinosaurs. We think the whole world forest burned. And that's about 10,000 teragrams of black carbon. So we've gone up 1, 2, 3, 4, 5, 6 orders of magnitude in black carbon here between the normal forest fires and the extinction of the dinosaurs. A war between India and Pakistan is probably 100 times bigger than a forest fire, but it's 10,000 times smaller than the extinction of the dinosaurs. And a nuclear winter is probably around 100 times smaller than the extinction of the dinosaurs. So this is kind of an image of what a nuclear winter might look like. A couple of years of sub-freezing temperatures. Nothing is going to grow at mid-latitudes in these conditions, which is why it potentially could kill most of the people on the planet. So right now we can't stop an asteroid impact. We just discovered an asteroid approaching the inner solar system with a radius of 100 kilometers, a comet from the Oort cloud, much bigger than the one that killed the dinosaurs. We only have a few months' notice of it arriving. There's nothing we could do about it. Fortunately, it's not coming within the orbit of Jupiter, so we're safe. But nevertheless, an object could come from the Oort cloud, where we would never see it, probably until about 6 months before it hit the Earth. And it would be incredibly difficult to stop. As you can see, if you've watched the movie lately, Don't Look Up, which is more about the political difficulty of convincing anybody to do anything. In the United States, movie makers and people who communicate this is really irritating to me, which is why I'm wasting your time on this. They don't imagine some scientist going on this asteroid and dealing with it. They don't imagine an astronaut dealing with this. They imagine that a couple of oil field workers can be put on a rocket and launched to the asteroid. And once they stop fighting over the girl and fighting over who's in charge, they dig a hole in the asteroid, which they think is the hard part, and set it a nuclear weapon and didn't blow it up, which of course is what happened on Don't Look Up and is not a good idea. You want to deflect the asteroid so it misses the Earth, which can be done if you have enough time. But it remains to be seen if we can prevent a nuclear conflict and global starvation. So history shows the world scientific community did something about this in the 1980s. They informed politicians. Politicians took them seriously at that time, and they worked to start building down nuclear arsenals. We're in a very dangerous situation right now because the President Putin has threatened to use nuclear weapons to keep people from defending the Ukraine. Of course, I don't think he's serious about it. He's just trying to intimidate people and keep them from defending the Ukraine. So I think it's most unlikely that we'll have a nuclear war. But another thing to think about is that this is very dangerous because in the United States and in Russia, the American president and the Russian president have someone who follows them around with the nuclear launch codes, because it only takes about 30 minutes for nuclear weapons from Russia to reach the United States or vice versa. So the American president, someone comes and whispers in his ear, oh, the Russians have launched their missiles. You have 30 minutes to end the world. What do you do? President Biden's likely to be asleep because he's an old man like me. Will he even wake up in the 30 minutes? Would he actually decide to launch the missiles? We don't know, but this is an incredibly dangerous thing to have the fate of humanity in the hands of a single person who could decide to launch the missiles because he felt like it, or because he had a mistake. There have been numerous cases that have gone to the president of Russia, for example, in which they thought there was a launch, and fortunately, they decided it was probably a false warning. And this is going to become even more dangerous. You should think about this, younger people, because people are developing new weapon systems like gliders. The point of the glider is it's not faster than a missile. What happens, it goes up and then it comes down and it glides at low altitude where it's very difficult to detect. meaning that you would have even less than 30 minutes to detect it, possibly only 10 minutes or less. No human being is going to be able to respond to that. Will the military turn over these weapons, or the nuclear-powered cruise missiles that Russia is building, or the drone submarines with large weapons that it wants to put into harbors? No human being will be able to decide what to do about that. Are we going to turn over a decision to artificial intelligence to launch our missiles and to detect them? That's where we're headed in the next few decades. Artificial intelligence will be given the power to decide whether human beings should live or die. In my mind, that is not a good solution for the Earth. It's basically committing us to destroying our civilization and ending intelligent life on the planet. We should be smarter than that. The dinosaurs couldn't do anything about it, but we're smart enough to know what could happen. We got to get rid of these weapons before artificial intelligence takes control of them. So thank you very much. Of course, there's other people that are involved in this research than me, and here's pictures of a few of them. Be happy to answer any questions you might have.
Thank you very much, Professor Toon. And it was a very scary talk in a way, but
exactly.
we all know. Okay, so let's go on with the Q&A, and let's see if we have questions from our audience. So if you have a questions, just write in the chat question, and then I will call you or send me a private message. So please do start. Let's see if there are questions. Well, while we wait, there's some questions come up. I want to ask just now a question myself. So you mentioned that scientists were successful in somehow influencing politicians, and then they started to reduce the arsenals. Do you think that now politicians are still listening, or will still? Are you hopeful that scientists in different countries would still be capable of influencing their politicians? I say this because we hear frequently about polarizations of pretty much anything. So also, whatever a scientist says, for example, I was thinking of scenarios like, okay, Brian Toon is illustrious professors, is American. So someone from Russia might say, oh, we shouldn't listen to him because he is basically saying these things so as to prevent us from using our weapons against the United States, and so on and so forth. What do you think?
Yes, I think that a politician in any given country will only listen to their own scientists. That's what happened with Gorbachev and Reagan. You can see Reagan said, American scientists have told me this, and Gorbachev said, Russian and American scientists have told us this. So when this work started, which I was a member of the group that discovered this in the early 1980s, as soon as we discovered it, we sent copies of our work to Russia, to Russian scientists that we knew, and encouraged them to repeat our calculations. And in the 1980s, there was a series of meetings under the International Council of Scientific Societies, which involved the national academies of most of the countries of the world. And they wrote a book, a two-book set of studies, finding that, yes, it appeared that the conclusions that were drawn are reasonable from what we knew, and that mass starvation would occur. And, so lots of countries were involved in investigating this. At this point in the United States, there are very few people, mostly the ones pictured right here, working on it. There's no funding to work on it, which most scientists need funding to pay their students and stuff. We're currently funded by a grant from the people who founded Facebook, and rather than any government institution or entity. There's no evidence I know of that the Department of Defense is spending any time thinking about this, or the Department of Energy, or any other nation's departments of any military people. So I think it's up to the scientists in the world to do something about this. People, I've been working on this for a long time, almost all that time with no funding from that. I just fit it in with the other things I study, like the ozone hole and volcanoes and planetary science. And, this is done with climate models that anybody can use. I have former students in China who use the NCAR community climate model. It's available to anybody in the world. I'm sure there are Chinese climate models that one could use to do these kinds of things. But yes, it's important for the science community worldwide to find out if what we're suggesting is correct, or if there's some big problem with it, something wrong with it. And people have to do this for their own countries and their own politicians and make them aware of this.
Thanks. Faye.
Yes, can everyone hear me? Okay.
Yes.
Yeah, thank you. So my question is about, Professor, what do you think of the role of public should play or could play in preventing catastrophe of nuclear winter? So in your talk, it seems like the main role is around those small community of scientists as well as politicians. But what about the ordinary people, general public? What kind of role do you think that we could play and will have a kind of impact on preventing such kind of catastrophe?
Yeah, so in the early 1980s, when this first came up, the average person was very concerned about nuclear weapons. People my age don't remember this because prior to 1963, when there were nuclear weapons tests in the atmosphere, long-lived radiation was building up in the atmosphere. Children's teeth were getting strontium-90 built up in them. And so there was a huge outcry about this. Linus Pauling, who had a Nobel Prize in chemistry, was very outspoken about this problem, and eventually won a Nobel Peace Prize for getting the countries of the world to stop nuclear weapons tests in the atmosphere. And this continued on as a memory into the 1980s because there were still lots of weapons tests going on underground. Of course, Japan is traumatized by having been attacked by nuclear weapons. There's all these Godzilla movies. Godzilla is supposed to be a mutant creature created by nuclear radiation from a war or from a reactor breakdown. There was a huge memory in society of this. And so people were marching in the streets complaining about it. So one thing that people in the United States don't know, I don't know about China. However, the United Nations just ratified a treaty banning nuclear weapons. So nuclear weapons are banned by the United Nations, just like landmines, biological weapons, and chemical weapons. This was hardly even mentioned in the United States, very not known to many people. And none of the nuclear weapon states signed onto this treaty, but many of the non-nuclear states ratified it. And in fact, if you look at the Earth, almost the entire southern hemisphere is a nuclear-free zone. About a third of the Earth's population is in nuclear-free zones. So there have been steps taken by people who are not scientists to complain to their politicians that something has to be done to curb the militaries of the world. It's not just a game to invent the most deadly weapon or to intimidate other people. It's very dangerous. And as Gorbachev said, people of morality have to stop this. So there are politicians who are very thoughtful, intelligent people. I've met lots of military people who are much more likely to understand the dangers of these weapons than politicians are, because they have to confront the realities of wars. Many of them are very thoughtful and realize that we should get rid of these weapons. It's a waste of money. Does a country like Pakistan really need to be investing huge amounts of its money in nuclear weapons? This is another problem that we're having is that, North Korea, for example, is a failed state. North Korea, is a dictatorship. Its citizens are starving. And instead of investing in their citizens, which, a moral country should do, they're investing in nuclear weapons and big armies. They should be like South Korea, make products like automobiles and dishwashers and stuff like that. They'd be much richer. And unfortunately, Russia is on that same path. Russia is totally dependent on fossil fuels. Fossil fuels are not going to be used by the end of this century because of the greenhouse effect. That will cause the collapse of the Russian economy. Is Russia doing anything about this? Are they developing their economy and making things that other people want? Are they investing in their population? No, they're investing in a military. So is the US. That money could be much better spent on investing in people's education and health and making everyone on the earth have better health and live a better life. So this is a decision that people have to make. Beatrice Finn, who has received the Nobel Peace Prize for this banning of the nuclear weapons, said, well, this will eventually be decided. The nuclear weapons will either be banned and done away with, or we will be banned and done away with. And, the decision is up to us.
I see there is a question in the chat. Abbott, do you want to unmute yourself? You can ask the question directly if you want.
Okay. My question is I think it's kind of unlikely to make the leaders of the world fully abandon the nuclear weapons, but what can we do further to make the situation better, or kind of try to avoid the chances to have a nuclear war as such, so that we don't have to afraid of die. I don't know.
Sure, I understand what you mean. I'm getting emails from all over the world these days. I got one recently from somebody in Italy, and they said, "Oh, I have a 3-year-old daughter, and I'm so afraid that Putin's going to start a nuclear war. I can't sleep at night, and I don't know what to do. Should I move to another country?" I've gotten messages like that from all over Europe, and people in, I usually say, well, you could move to New Zealand or Australia. Then I get emails from people in New Zealand and Australia saying, well, will radiation reach me? And I said, no, I don't think radiation will be a global problem, but you're going to have a food shortage to deal with if this ever happened. But the main message is that this isn't going to happen. It's very unlikely to happen on purpose here. It's it would take some massive accident or mad person to do this. But nevertheless, we shouldn't have to live in fear of this. We need to have Russia calm down, and for this current situation to relax, and for some dialogue to start again between Russia and the United States and nuclear weapons. But we also need to involve other countries in this. We need to get China and India and Pakistan, and Britain and France and other countries to understand also that their nuclear arsenals are dangerous. But mostly Russia and the United States have 90% of the nuclear weapons. They need to continue the build down of weapons that they started in the 1980s. And continue to reduce the numbers of weapons instead of investing in developing new weapons, which both countries are doing, investing in new weapons. They should stop that. And we need treaties. We have to have agreements between the two countries to get some treaties to stop this before we have to get into an artificial intelligence kind of situation. That requires that countries talk to each other instead of invading each other. And, armed conflict, there's no country involved in armed conflict that's prosperous. Countries like China have shown great wisdom in not building huge arsenals and instead investing in their people. That's one reason that China is a booming economy, is instead of investing in a huge amount of resources in its military, It's, investing its resources in developing its country. And we need everybody to follow an example like that. And we need Russia and the United States to stop being adversaries and, develop a more peaceful way of communicating. And how you achieve this varies from country to country. I think politicians do read things. They do know what people in universities think. They're very powerful people in Chinese universities. China has some of the leading universities in the world. United States, for example, is full of Chinese citizens who have come here and are now leading professors in various fields. So there's plenty of well-educated people in China, who can look into these kinds of issues and inform their politicians about them. It doesn't have to be a huge confrontation. It doesn't have to be marching in the streets. It can simply be information transfer. That's what happened in the 1980s. Is while there were demonstrations going on because people were very upset about nuclear weapons tests, it was still the scientists just working the normal way. They did studies, they found results, they reported them to the administrators of the agencies they work for. There's the Chinese Academy of Sciences. I don't understand the structure of that totally, but can obviously report these things to higher administrators there, and they certainly talk to politicians in higher levels. So one can very peacefully communicate these issues to higher levels in the governments.
Great, thanks. Any other questions? Right, so let me ask another one. So what's your position on nuclear deterrence, and the main reasons as to why there was this buildup of arsenals was that of ensuring this mutual assured destruction. Does it work? Does it not work? Do you think it's irrational also from a game theoretical point of view? What do you think?
Well, mutual assured destruction has not prevented wars. For example, there's a war going on right now, and there's 2 nuclear weapon states involved in it. It's a conventional war, fortunately, but it hasn't stopped that war, although Putin hoped that would stop the US from intervening. You can look at lots of other conflicts. Who won the Vietnam War? It wasn't the United States, it was the Vietnamese. Who won the war between Argentina and Britain over the Falkland Islands? Well, maybe that was Britain, but it didn't stop the Argentinians from starting a war, even though they didn't have nuclear weapons. Who won the war in Afghanistan? It wasn't Russia and it wasn't the US, it was the Afghanistanis. And they didn't have nuclear weapons. So nuclear, there was a case with India and Pakistan. As soon as India and Pakistan had both tested nuclear weapons, Pakistan decided it could invade Kashmir, and the Indians wouldn't do anything about it. And that wasn't true. The Indians immediately fought back and pushed the Pakistanis back out of Kashmir. So having nuclear weapons there didn't stop a conflict either. So mutual assured destruction is not preventing wars. It is true that we haven't had a global conflict in quite a while. Possibly that's because of nuclear weapons. But it's also possible that we're just barely surviving here because of good luck. There have been numerous cases where nuclear weapons have almost been used. There's a frightening book by Daniel Ellsberg that was just written called The Doomsday Machine. And he describes the Cuban Missile Crisis in 1963. Russia was attempting to move large missiles into Cuba to use against the United States. And we put up a blockade around Cuba. And there were submarines there. We decided that, wouldn't it be fun to throw hand grenades over the side and see if we can scare them? And I think there were 6 Russian submarines there. And Fortunately, they didn't shoot their nuclear torpedoes, which we didn't know about. Some of them thought they were being depth charged. They came to the surface, their captains got fired. One of the captains decided he was going to fire his nuclear torpedoes, but fortunately there was a political officer on the submarine who prevented him from doing that. And even worse, in Cuba already, there were 50 tactical nuclear weapons that the United States didn't know about at the time. And had the United States sent an army in to invade Cuba, there would have been a nuclear conflict right there because of it. So we're just fortunate that there wasn't a nuclear war in 1963 over the Cuban Missile Problem. And there have been, as I mentioned before, usually, this is one thing that scares me about artificial intelligence. Usually, whenever somebody puts in a new detection system looking for missile launches, it leads to a false detection of a launch. So this happened when Russia put up some satellites to attempt to detect launches, and they thought they saw a launch of about 7 missiles. And the military man who observed this thought, well, this doesn't make any sense that there'd only be 7 missiles launched. And so he didn't report it up the chain of command. And it turned out it was just reflections from clouds that were being seen. And it was just fortunate that he didn't report this up the chain of command. And he's given a lot of credit for preventing a nuclear conflict there. There was another case when there was a missile launch from Sweden of a sounding rocket. Normally these are reported to Russia, and so they know what they are. But in this case, it was mistaken as a launch of a missile that was going to blow up in the upper atmosphere and knock out all the electronics in Russia. And this was reported up to the president of Russia, and he decided, well, this was a false alarm. I can say, I myself was involved in some studies of the ozone hole. We were in northern Sweden, and we had a high altitude aircraft, a U-2 aircraft, which is like the one that was shot down over Russia decades before. And we asked for permission to fly over Russia because that was where the ozone loss was occurring. And we had a Russian general there who said, yes, he would inform the people on the Russian islands that they knew we were there and it was okay. And this was in the early 1990s when the Cold War seemed to have ended. And, I flew along with this in a lower altitude airplane. We flew right over the Russian submarine bases in the northern part of Russia. We flew as far as the Ural Mountains. The ozone hole was in the Arctic at that time, right overhead. It was a totally scientific mission, had nothing to do with any Soviet or Russian military facilities, but it was a very nervous thing to do. But at that time, the countries were cooperating. People thought when the Soviet Union collapsed in 1992, that peace had broken out on the earth, and that people would settle their differences by having meetings and talking about the problems and working out their differences, and that we would get rid of nuclear weapons. And unfortunately, that didn't turn out that way. But nevertheless, we can build down nuclear weapons, and we can build them down slowly. As I've mentioned, there's only 200 cities in Russia with more than 100,000 people. The United States decided in the 1950s it only needed about 200 weapons to destroy half of the cities in Russia. And, we have much bigger weapons now. At that time, they were Hiroshima bombs. So we only need 200 nuclear weapons to basically destroy Russia. Russia only needs 300 weapons to destroy the United States. So we could easily build down from 4,000 weapons to 400 weapons. And then we would be like China. We'd have about the same number of weapons. At that point, probably both countries could defend themselves against nuclear missiles by building missile defense systems. I personally don't think missile defense systems work. I don't think there's any evidence that the American missile defense system would do anything at all to stop a Russian attack. But if you got down to a small enough number of missiles, you might have some hope of doing it. So what's the point of this? I mean, if you're a utopian person, who thinks the world is ever going to do something perfect, You might think, oh, well, we'll just all get rid of all the missiles. You know, I don't think that's practical. I think that the political powers will never trust each other. And we can only build down slowly by keeping track of what each other has and feeling comfortable that both sides are honest and not cheating. But we can build down that way because we have quite a lot of margin to reserve the mutual assured destruction system. Alan Roebuck and I, and Carl Sagan also back in the day, but Alan and I changed acronyms to something called SAD, S-A-D, instead of MAD, M-A-D. SAD means self-assured destruction. I've already showed you in this talk that with a few hundred nuclear weapons of modest yield, you can kill half the people on the planet by a nuclear winter. It would be suicidal to launch a nuclear attack against another country, even if they didn't attack you back, because you would burn so much material to produce a global climate change. It would destroy agriculture. So what do? I think we build down slowly and slowly until we gain more confidence in each other. There's really no reason for all this international antagonism. I mean, there's no reason for, the average American doesn't care about the average Russian. They're in a different continent. If they would just stop invading people, we wouldn't care what they did. They could be a perfectly normal European country. Of course, half the country or more is in Asia, but a perfectly normal European country, just like everybody else, and let their people go wherever they wanted. And Russia has beautiful cities and amazing technology and various things and a great history over a long time frame. And there's no reason for the countries to be adversarial. The same is true in China. There's no reason for the United States and China to be adversarial. Half the stuff in my house is made in China. I've got all kinds of graduate students who are Chinese and made great contributions to science here. Why would I want to be adversarial to China? It's another country with a fabulous history that have gone on for thousands of years and beautiful countryside and amazingly productive people. I don't see any reason why we have to become adversaries. It's counterproductive to human society.
So very last question from me again. So is it fair to say that for you, it's basically, let's say the greatest risk probably is a mistake, it's not an intentional use of nuclear weapons, insofar as we assume that world leaders do not completely go mad. So it's more likely that a nuclear winter scenario will happen because of some sort of mistake.
Yes, I think that's the situation. Putin knows that Russia would be just a smoldering ruin if he launched nuclear weapons. And I don't know about Donald Trump, who made a lot of comments that indicated he didn't know much about this problem, but I'm sure that the current president realizes that if there were a nuclear war, that there'd be not much left of the United States. Would China be attacked in a nuclear war? I don't know why they would be, or it doesn't make any sense. But you never know what military planners are thinking. No one would want to start a nuclear war on purpose. No one rational would want to do that. And so these weapons are useless. They can't be used in a nuclear conflict. They're just sitting in the ground rotting, burning up huge amounts of money for something that can never be used. It's just a waste of money. And unfortunately, accidents can happen. And we're moving toward a situation right now where it's much more likely that we're going to have an accident. This is just a scenario in which accidents have occurred in the past, when some new machine gets put in place to detect the need for a retaliation. And if we turn it over to artificial intelligence, which is what we're going to have to do because of these new weapons people are developing, that's just a scenario that's ripe for having a mistake.
I understand. Okay, well, Are there no further questions from our audience or from the members? If no, then we can thank Professor Toon again. Thanks a lot for your talk.
Thank you for inviting me.
Thanks a lot. And so that's all for today. And other people are saying thank you. Okay, so Professor Toon, again, thank you very much. And thanks everyone for joining us today.
Goodbye.
Bye-bye.